I am a recent graduate from Makerere University in Uganda. I graduated with a bachelor's degree in land surveying and geomatics. Currently, I'm working part-time with an organization called MAPRI Initiative, which deals with the use of GIS to handle real-world problems. To proceed further, during my internship, I've been able to gain skills in the use of various Esri and ArcGIS tools. I've also gotten experience to work with programming, Python programming, which I had not had a chance to deal with. And I've also been able to network with various people, which I believe will be beneficial for me as we're going forward. So, wrapping up my introduction, let me begin my presentation. So the topic that I was given is infrastructure inspection workflows with ArcGIS drone to map. So giving a background about my project, as I think everyone is quite conversant with, infrastructure can be categorized into various sectors like buildings, roads, energy utilities, and a various number of sectors. And all these factors, as time goes by, they experience wear and tear. And therefore, inspection is needed to ensure that these structures are working in the best condition that is needed for them. Currently, the main form of inspection that is carried out for infrastructure is visual on-site observation, such as like building inspectors go to the ground, they look around the building, or if it's the road or any other infrastructure, and they identify if there's a problem or a potential problem that may come about. So the problem with this current inspection approach is that it is limited due to the inspector's line of sight. For an incident, if the inspection feature is a tall building, the on-ground inspector may not be able to see specific areas around the building that have issues, and therefore, if those issues are not addressed, it can result into negative consequences while moving forward. So the solution that I am proposing with this project is the use of drone imagery and the ArcGIS drone to map tool to facilitate a more efficient and safer infrastructure condition inspection. ArcGIS drone to map has the ability to process the drone images and be able to develop other products like 2D and 3D products that can help speed up or make the inspection of buildings more efficient. To give a brief introduction of ArcGIS Drone to Map, it is one of the ArcGIS tools that is used as it involves the use of drone images as their main data input. So the functions that ArcGIS Drone to Map can do, it can permit image processing, as I think some of you who have worked with drone data, you can be able to process that data inside ArcGIS Drone to Map and be able to generate 2D and 3D products that can facilitate other analysis. ArcGIS Drone to Map also permits georeferencing of drone images. That is basically giving those images world coordinates that can permit them to be located on ground. It can also permit 2D mapping, as I mentioned, through if you have a variety of drone images, you can be able to generate an orthomosaic, which is basically a geometrically corrected image of all a single image, which collects all the other images and in their correct positions as they would see them on ground. And other forms of 2D products can be DSMs and DATMs, which can also be generated and then used for other activities like land cover mapping and urban planning mapping and all those sorts of activities. It can also generate 3D maps, which I think would be a main use for my project, infrastructure inspection. As I mentioned in my problem statement, that there is a limitation in the way that buildings are inspected in the event that they are tall buildings. So ArcGIS Drone to Map can also be used for inspection analysis, which I've stated, and also change detection. Because if you're given a situation where you have drone images that have been collected from different periods of time, you can be able to analyze the different changes or areas that may need to be addressed from such information. So to go deep into how I can be able to use ArcGIS for my inspection is that I can start with data management. If I've collected various drone images for the area that I need to be inspected, I can then input them into, in this case, ArcGIS drone to map, where I can be able to store those images and even process them. From there on, I can proceed to perform analysis within the ArcGIS environment and also generate visualizations such as web maps or apps and dashboards, which will then permit me to be able to make a decision on basing on what I have analyzed and visualized. From that decision, I can be able to share the results that I've gotten with the prospective parties that are interested. In the case of this project, maybe with the building owner or the building inspectors. So for my project, I am using my study area is Buchanan Airport Control Tower. Control Tower is basically a building where air traffic controllers guide and communicate with pilots as they're landing or taking off or setting off or approaching to the airport. So I think from that information, you can analyze that the safety of such a building is very crucial. And therefore, I used it as my study area for my inspection workflow. I was able to obtain 200 drone images for this specific building. To give a brief overview of how I was able to perform this analysis, as I said, I was able to get 200 raw images of the building that were taken by a drone from different aspects and sides of the building to allow for better analysis. So after obtaining those images, I put them into the ArcGIS drone to map environment, where I was able to come up with an orthomosaic, which I think you can see as the second image, which it basically is an X and Y representation of how that building looks on ground. I then proceeded also to generate a 3D product from the images that I got. And from that 3D product, I can also see the height aspect, which would now counteract the limitation that I mentioned from the visual inspection. The main objectives of my project is to develop a building inspection workflow using the drone images and ArcGIS drone to map to efficiently capture, analyze, and visualize the building conditions. So to be specific, I intend to identify the condition of the building and therefore facilitate early detection of the structures or early detection of structural issues, and therefore carry out a plan basing on what I have observed. So this is my architecture that I followed for this procedure. The main input was the drone images, which I inputted into the ArcGIS environment, specifically the drone to map, which allowed me to generate 2D and 3D projects, like such as the orthomosaics and the 3D meshes that I have mentioned. After generating that, I performed analysis within the ArcGIS environment, which allowed me to also generate inspection information about what I had seen that then facilitated me to visualize that information for better understanding by the stakeholders. And that information was then stored in the ArcGIS platform where it can be accessed by the public or the interested parties. I'm going to give a brief demo of how I carried out all these activities in ArcGIS Gentuma. I believe you can see my screen. I think so, yes. So this is in the ArcGIS drone to map environment. As I demonstrated previously, after inputting all the raw images that I was able to collect, I generated a 2D product, which is this orthomosaic. The procedure that I passed through is I basically went to analysis, the managing page, where I was able to, as you can see here, there are various number of products that can be generated if you input in your images. So to carry out such an image, I would just tick what I want. Either I want a DSM or a DTM. And then after doing that, I would click start processing, which will then be able to generate the output that I require. So I generated a 2D map, and then I also generated a 3D map of my area of interest. As you can see, I think you can see from here, this is a 3D map showcasing how the building looks like on ground through various sections. These lines, the orange lines that you can see, are basically how the drone flew around, and then the blue line, the blue points, are the centers of all the images that I was able to generate. So after I generated this image, my next step was to carry out the inspection, which was the main goal of this research project. So I then went forward to perform analysis using the inspection tool in ArcGIS Drone to Map. So before carrying out the inspection, I needed to generate criteria of what information did I want to get out of this inspection. For example, in this case, I wanted information about as you can see here, I wanted information such as the name of the feature. Is it a window? Is it a building? In what condition is it in? Is it in excellent condition, very good condition? And then any notes that I might have, does it require maintenance and such information? I needed that for my report. So to perform this analysis, I identify an area, for example, maybe the spotlight. For example, this is the spotlight at the top of the building, which I think would not be able to easily access if I was performing manual inspection. So I identify it, I specify this is the image that I want to analyze, and it will be able to collect all the images that can be able to allow me to clearly see the specific point if I want to analyze that. As you can see here, I've been able to generate 5 images that can clearly show that spotlight. So as I'm performing my inspection, I zoom in into the area that I want to identify. Then if I want to do a polygon or an area, from the inspection editor, I go and form an image around what I want. Then after that, if I want to include some images in my report, I stick them to be included. Then I fill out this schema that I set up, such as this a spotlight, who inspected it, and all that information. So after doing all that, I was able to generate a number of inspections for different features, on the building. As you can see here, I think you can see some of them as I'm describing. So I was able, as I mentioned, I set the parameters for the condition to be the excellent, poor, or in good condition. So I set different colors to represent the condition of the structure that I've inspected to permit faster and easier addressing of such issues. So proceeding forward, I was able to also generate a web app to be able to visually see the information that I generated. So I think you can see my screen. Yes. So from this web app, I can be able to even carry out more inspections that maybe I didn't see in either 2D or in a 3D around the buildings. For example, in this case, there were cracks on the surface, which could potentially lead to, if not addressed, they may cause structural damage to the building. Or, for example, let me see, I think this transformer yard had a bit of mold at the bottom, which if also left unattended can make the ground surface weak. So I was able to address quite a number of these issues. And for even better analysis, I was able to, if a study had been done on the area, I can be able to analyze if maybe that issue has been addressed. So I would be able to maybe search here, search for like maybe the transformer then it will go to the specific area, and then all the information that I recorded, such as which condition is it in poor condition, or who was the inspector, is maintenance needed, what notes did I observe from that, all that information can be easily displayed. And I think also I just mentioned the schema that I was following for the coloring that I was using to identify excellent condition, it would be in blue. And I think from this transformer yard, you can see it's in poor condition due to the orange color that it represents. So yes, this is the web app that I was able to generate showing this information. I was also able to generate a dashboard to clearly represent maybe the numerical statistical information about my project. For example, you can see a bar graph here showing the percentage of how much was of the inspected features, what condition were they in. And from this analysis, you can see that a majority of the features that are inspected were in poor condition, and therefore an immediate inspection is required. And also it can also show which features I was able to identify and the condition in which they're in. So I guess to conclude my project, I was able to identify a few benefits from this solution, which would one of them being reduce inspection time. As I mentioned, if inside a situation, if I'm able to analyze which areas need to be inspected, and maybe if there are tall buildings, I can be able to say that, oh, I should when I reach ground, I go to the specific area, and maybe if it's at a high area, I carry a ladder. So such maybe inspection time is reduced because in the event if I went on ground without knowing any information, I'd have to maybe wait if I've not gone with the required equipment, I'd have to wait and get the required equipment. Another benefit is that it automates data collection and analysis, which facilitates faster decision making. I think I have clearly emphasized this as if I'm able to identify all the areas that need attention, and if maybe I had analyzed and no areas needed attention, I would then not to go to the ground, which would be faster decision making. I'm able to use high resolution data imagery, which can allow me to see even maybe cracks on the wall. So it's a very good approach for such an inspection. I would also be able to reduce the labor costs because if I know how much is needed, I won't need to take a number of people to inspect every single area of the land if when I know the specific area that inspection needs to be done. It can also permit early detection of issues. I think from some of the few features that I showed, like the transformer yard or the spotlight, if I can be able to identify that this area needs to be addressed immediately, they can send people on ground to go and address it other than first going on ground, and then they might identify other areas that are not in urgent need of attention. And then also another main aspect is that it eliminates the need for inspectors to assess hazardous areas. For example, if they're obstructed, I can identify that from my analysis and be able to allow the inspectors to properly plan how they will address or assess this area. So yes, thank you very much for your time. That was my project, and I'd like to invite my colleague, Sarah Margaret, to continue with her project from there. Thank you.
Thank you, Sheila, for the presentation. I'm going to share my screen. Good morning, everyone. My name is Margaret Sarah Wanjiru Njoroge. My background is in geomatics engineering and geospatial information systems from Jomo Kenyatta University of Agriculture and Technology. I also just finalized my master's in urban and regional planning from the University of Nairobi. It has been a privilege to intern at S3 Eastern Africa. The internship has not only solidified my academic knowledge, but it has provided invaluable insights into professional workflows, the value of teamwork, and the vast capabilities of the ArcGIS products to solve practical physical challenges, and this has left me awakened and challenged to continue learning even beyond the experience. Onto my project. I was assigned a project in crop traceability system, and I decided to focus on coffee for global market because coffee is grown in our country, Kenya, majorly cultivated primarily for sale to the global market, and therefore I decided to base my project on it so that we can analyze how we can be able to position ourselves for global markets. So a brief background on coffee in our country. These are the major areas where we have coffee growing in the country. And there are approximately 800 farmers in the country with only 30% counted by the large estates and a big 70% by small scale farmers. And this translates to our country being the 17th highest global producer. In terms of the contribution to the economy, the annual contribution to the economy by coffee is 1 billion, and the market size for coffee is continually growing. As at 2023, we were at 1.1 billion, and that is projected to continue rising. Some of the main challenges facing coffee farming in Kenya include fluctuating prices, global prices, and the dynamic policy for exports that keep changing, and farmers have to keep adjusting and building compliance towards. Also, climate change is a big issue as it affects the weather conditions. The rising temperatures leads to increased pests and diseases. There's a lot of erratic weather events such as floods and droughts, and this affects the farming conditions and also hastens the coffee tree aging process, and overall affects the quality of the farming production. Another big challenge is the competing land uses, where we have farmers deciding to change from one land use to another, from coffee to other land uses, such as having more built up areas, and also deforestation, where we have the reverse, where people clear trees so that they can plant coffee because of the speculation of having more value in that. Some of the solutions we can adapt: a sustainable practice. It's a wholesome solution to these challenges. Sustainable practice to coffee farming. A main one that is globally advocated is agroforestry, which is basically growing trees under tree canopy. This requires less fertilization because coffee grown under shade is provided by those trees a lot of nutrients to the coffee plants that protect it. They naturally protect the coffee trees, and they are natural predators to help in control of coffee pests. They also have better flavor and better aroma, and that is highly encouraged. Also, another sustainable practice is compliance to global policies, such as new European Union deforestation policies that have been developed so that we continue to service that market. So it is important for us to understand what is the European Union deforestation regulations that I'm talking about. These are new regulations that have been adopted by the European Union to curb deforestation and forest degradation linked to their market. They came up with a list of products which they felt were contributing to deforestation worldwide. Their main goal is to ensure that they do not contribute to deforestation directly or indirectly through the products that they import into their market. A broader effort by the EU is to meet the its climate goals and biodiversity targets by encouraging sustainable land use practices globally. It is also important to note that these regulations apply to all companies, regardless of their size, and this therefore includes our small-scale farmers, who are quite a lot, and because they have direct or indirect supply links to deforestation and for the purposes of export. So some of the listed products on EU regulations for deforestation are cocoa, soy, coffee, palm oil, cattle, rubber, and wood. And for this project, we focused on coffee because that is among the products, that is the main commodity that comes from our country. So we do a brief definitions for this. One of the key, part of the key objectives of the EUDR regulations are traceability, due diligence, and compliance. And it is important for us to understand the terms traceability as defined by the EU, which is the action of assessing the origin or the source of a particular commodity. Then deforestation, it is the long-term removal of trees from a forested site to pave way for another use, in this case to pave way for coffee. A problem statement is failure to comply. Our country failing to comply to these new regulations would make Kenya lose the significant European Union coffee market, which is quite significant because it accounts for 55% of our coffee market, and this makes it the largest market for coffee. And GIS-based solution then is timely. First, to establish whether there is any deforestation on our farmlands, and also encourage our farmers to adopt sustainable practices so that we can continue supplying coffee. My objective is to develop a GIS solution to assist farmers access global markets through adherence to the new policies. Specific objective is to perform a land use land cover analysis on farmlands using the 2020 as the baseline year, because that is a year provided by the European Union as the baseline year for land use land cover change analysis. Then develop a platform for farmers to get information for whether their farms have complied or are compliant or not. So the reason why I adopted ArcGIS is because I appreciate it as a comprehensive system for agriculture solutions. Its ability to provide insights provides a platform where one can derive informed decision making, and provide a solution, provide a problem solving atmosphere and strategic planning. It has the ability to turn spatial data into actionable intelligence and enable analysis. Also, it's a system of engagement where it's basically fostering interaction, collaboration, and communication among users and stakeholders through applications and maps. This achieves active participation and the ability to share real-time interaction with spatial data. It is also a system of records, because you're able to accommodate and manage critical information, and this makes it act like a central database for information, and you're able to get data, accurate data, consistent data, up to date, and accessible. My solution architecture involves a data and records management platform where we get the satellite imageries and the records for farms collected together and put in the ArcGIS online platform, and after performing the analysis, we're able to present that in a platform like the experience builder and the story maps for interactions with the stakeholders, for visualization, for decision making, planning, and administration of the same. For as part of my solution was I highly used this solution, this application by the ArcGIS suits. In the ArcGIS suits, it's called ArcGIS Sentinel-2 Land Cover Land Explorer. Ideally, initially, I would have downloaded the images and performed the classification for me to achieve this, but I found this very useful. First, I identified an area that would have a lot of coffee in it, and I searched for it. This is Kambui area within Kiambu County, and as you can see, it readily has the land use land cover classes with that are very easy to understand, and this is downloadable. You can download this and publish it to other ArcGIS platform to combine with any other data. It has resources up to 2020, and as we discussed, I was using 2020 as my basis, and so I was able to get the images for those two timelines and compare them together with other data sets. And this is in appreciation of the ArcGIS, the vast applications provided by the S3. So in ArcGIS Pro, I was able to digitize the farmlands and overlay them on the downloaded images, and I was able to crop my study area for analysis. So here we have the several lands farmlands that are growing coffee, and we have a few identified coffee factories that are near there. Using spatial analysis, I was also able to assign the nearest farmlands to the nearest coffee factories, which would be important aspect in traceability, because they harvest and take them to factories for processing even before they are taken to the exporters, and therefore that aspect of traceability is important. So here we have the land use map for 2020, for the year 2020, and we also have the year 2023. And it is not very easy it is a good way to visualize the two aspects, but I thought it's important to also make it easier for someone to appreciate, and that is why I decided to also visualize the same on a experience builder. Hopefully you can see my screen. So we have the map for the two layers combined in one. Here you can appreciate that one can be able to swipe through different layers. We have the leading layer, which is 2020, which is the baseline year, and the trailing layer, which is the 2023. And you can just be able to swipe and appreciate the changes in the land use land cover. Here you can also search for a particular farmland. For instance, we can decide to check the Ridgeways Ridge View Farm. Yeah, and the map can zoom to that, and you can actually see and appreciate how easy it is to analyze whether there has been any changes in land use. Also, I did a few queries on the data, where I was able to perform queries on various varieties of coffee. We have Robusta in Kenya. We also have Arabica. So out of my data sets, I was able to run a query that would show how many farms, for instance, are processing, are farming Arabica. And also we can be able to appreciate that. Sorry. Yeah. Yeah, we can be able to appreciate the different queries. And this can be shown on the map. Yeah. And as well, you can see, you can still swipe and see the changes in land uses, and therefore one can do a brief on how many farmlands that have processing a farming Arabica coffee variety would be affected by the regulations. Also, we have a table that can be able to show that as well in a tabular, we can view in table, and that can be displayed on this table. Also, I was able to show how many farms are assigned to a particular factory, and this can also be shown on the table. One can be able to see there are 8 farms assigned to this Kiambu Coffee Haven, and this together with this pie chart, which shows the capacity of each coffee coffee factory, one can be able to see whether there's one that is overburdened, and if they're able to meet the needs. Also, I did a bar graph that was using I had done calculations on ArcGIS Pro, where I calculated for tree cover for every farmland, and for 2023 and for 2022, for 2023 and 2020, I was able to get a bar graph that shows that indeed there's a lot of deforestation that has taken place between 2020 and 2023. And therefore, this substantiates the findings by the European Union that indeed farmers are deforesting their lands and planting coffee, and that is not a sustainable, it is not a sustainable practice. So to conclude my presentation, solution benefit would be, the solution presents spatially sensitive compliance as required by the European Union by providing farmers information and the ability to mitigate risk and adhere to the regulatory framework, and thus streamline the compliance process. The solution will also improve coffee data management and enhance traceability as well as stakeholder engagements. And it will also encourage sustainable coffee farming practices, which will contribute to combating climate change, which would be a benefit to our country as well as to the globe. So I thank you so much for your time, and I am going to present and request my colleague Celestine to take on. Thank you.
Hello team. Let me share with you my screen. My name is Celestine Imai Barasa. I am a graduate from Coratina University with a bachelor's degree in geography. Having been part of the Q4 2024 has been a great opportunity, not only to learn more on the SL products, but to have the interaction with the top-notch minds within the organization. And during my internship period, I became very knowledgeable on what indeed SL does and what it produces, the prototype workflow, and this opportunity makes me humble to have been part of the great SL team for this entire period. With the gain knowledge, I hope to leverage my learned skills on GIS and knowledge on S3 products to be able to solve issues affecting my community and the world at large. On the previous side, on working with data interoperability using any data, I focused on data on out-of-house advertisement tools, and to be specific, I measured on billboards along the Kenyan roads. On defining what indeed this ArcGIS interoperability is, we can always have two definitions. We can define this as a product being an extension for ArcGIS Pro and ArcGIS Enterprises, and as a technology, ArcGIS data interoperability is an S3 no-code integration simulating the FME capabilities capable of doing extraction, transformation, and loading. On why this extension is so essential to our industries. Using the extension, it can be able to do data integration. It can be able to help us do a data cleaning, in essence, removing barriers in the data to be able to be read in any other system using any other format. With this very same extent, with this very technology, we are in a position to share our real-time data within the organization and even our clients. We can do the data conversion, and it is in essence, we can always have one data from one format be transformed into our desired output data format. And one essential importance for this very same technology is to automate our data integration process in place. This system comes to replace the previous existing systems which always needed a manual integration. But with the data interoperability, we can always automate it. And in essence, we can always save time and money as we maximize on our output. My problem statement was in line with my country, Kenya, and as one of the out-of-home advertising tools, billboards in our roads have always had challenges when it comes to safety, regulation, and maintenance. And more to this, their placement has always been in need of constant inspection, and this as shown in the picture to help in reducing such incidences. And the existing systems of inspections tend to lack that seamless integration brought by the ArcGIS interoperability between various sources related to real-time data source, geographic, and demographic locations. And as a result of all these issues, owners and all decision makers tend to lack that effective tool to manage and be able to maintain all these tools along the roads across the country in this case, and this has always been in any other country in the world. With the extension in this context, it helps us to enhance the targeting, placement, and the performance of all these campaign tools by doing the analysis, integration of various real-time data, demographic and geographic data. And this is so vital in ensuring that the strategic and effective approach that are aligned to the desire by the audience and the objectives of the organization. In this project, my objectives are, I did realign my objective, and one is on streamlining data integration, data standardization, and improve inspection efficiency by automation. And in the essence of all these objectives are all in line with the aspect of data interoperability as a technology by ESRI, in the essence of always having a maximum, always having our instances maximizing on their output always. And my solution architecture is as follows. To be able to get this data, I did use the field maps and the quick capture. In that sense, all these tools are vital in the manner we can use field maps to be able to get the specific location of our billboard, and quick capture can enhance the capabilities of field maps by by capturing pictures of their billboard, which entails all owner, the date of inspection, and the condition of the billboard itself. And having this data in the CSV format, I did use the ArcGIS Pro, and within this ArcGIS system, I did the data transformation using the FME engine, which involves the data extraction, data transformation, and having our output as a writer. After this data, this results from the transformation and workflow is always analyzed and visualized by the GIS users, and in this case can be spatial specialists, researchers, planners, and any other interested party who finds it so important that this data can be used to solve issues related to the placement of our data, billboards in this case. And our fourth aspect will be maintenance and report. In this case, the report generated all from this step 3 can be used by the executive and stakeholders in communicating, decision making, planning, and can be used for collaboration to ensure there's maximizing the output of the business. In this case, I will want to show how the extension works, and I would like to share my screen on. Thank you. And in ArcGIS in ArcGIS Pro, we can always access our extension by coming to analysis, and here it is. And here it is. With the data interoperability, we have 3 aspects on which is the workbench, data inspector, and a quick translator. And to showcase what all this will mean, in this case for the workbench, we can always see it as a tool for data conversion, sharing, and we can do the validation, transformation, and integration of the data we are working with. And with this data inspector, it lets us visualize and explore any other format against our area online background, and can always also use it to export a selected feature to another format. And the quick translator, it helps us do the simple translation between formats from one format to another. And to showcase how our extension works, can always have to come here. We'll always need to create a new special using the good. With this, we can always rename our our feature name. You can copy this very same here, and in this case it can allow us, sorry for that, can allow us have some space between these words, contrary to this, which cannot allow us to do that. And so, and in confirming our workspace, yeah, it is good. We can let it run in it takes a little bit of time. Let's give it a little bit of time for it to run. Good. And this is how our extensions pops out. It will load the transformers, check license, and initialize our windows, and before it comes out. Thank you. And this is one of the aspects I was saying. Now this is the workbench, an area we can do our transformation. In this case, I intend to use the CSV that I have. I'm showcasing how this tool is so vital. In essence, we can convert any that you have to any data you desire to be converted to. In this case, we work with a billboard. We can always check the parameters of our data, confirm all is good. And this is so vital because your end format needs to have all this. Thank you. And I intend to convert this into GeoJSON. JSON format, and data set is always the name you want your output to be named. In this case, we'll just name it billboard JSON. It's also vital we can confirm its parameters. In this case, you can rename this the very same name you've written over there, or leave it this way, but your output will always be the same. This doesn't change your output. In this case, we can use the static schema and notice because the static schema works very well and doesn't have any issues. Can click on express an expression that we have the translation going on, and back below here we can see the movement. Within a few seconds we can see it is successful. It is successful, and we can tend to maximize this. Thank you. Thank you. We can always tend to get out the confusion on why we are converting CSV to CSV, because the output tend just to take the name for our reader, that is the input format, and we can always rename it to JSON. Use attributes. I just have to check that. Thank you. So we are doing that. I'm trying to illustrate on the capabilities of this technology on being able to convert any data you have into any data you desire it to be read in any other system, maybe that this one is not capable of being read directly to. So to have this as an output, we can always check it on our attributes. Thank you. And with this, we can utilize this. This is a run just contain. We tend to run it here. In essence, we are able to confirm if indeed the data we have has all attributes we consider to be having. So we tend to run it here. This is an indication there's a translation going, and we give it a little bit of time to showcase. Good. So you see the difference here. We can able to click here to inspect our data, contrary to just a few seconds ago before we had run into this. With this, we can always confirm the data we are having. Good. And then to reduce it that way. Good. So to showcase how vital the tool is, it can also give you a hint in our map, where is it your data is from. With this coordinate system, the shows it where your data is from, and we can also confirm our export attributes as being the very same we had before, and the geometry we have it. Good. And in this case, there's some data you might not have this, and S-ray having this product will always help you to be able to give your data the geocoordinates by using the transformers I'm just going to showcase in a few minutes. So vital is also to check if your data has this very same points you had in your CSV format. In my case, they were 49. In this case, my data is good. And so to be able to transform it into any transformer you want to use for it to convert into output, we always need to consider this second aspect of run from contained. We tend to give this we tend to transmit this data forward to any transformer you can intend to use it here. Give it a little bit time. It is successful. Translation was successful. And so in this case, we can tend to choose in the transformation section. We have so many transformers. In this case, I will showcase on how an attribute manager. Sorry. I will tend to showcase on how an attribute manager is vital when you want to transfer your data from one data format into another. And this showcases an aspect of why data interoperability is vital, because it tends to remove barriers that can hinder the seamless translation from one data format, from one system into another. So with this attribute acting like an aspect to help you clean your data, to be able to be read in data that system you tend your data to be, we tend to use this attribute manager. Why is this vital? Because we intend to confirm our data using these attribute types. We tend to confirm our data if indeed they are in a position or in a state compatible with our intended system. And discuss Icon 64. Good. Good. Can consider. Okay. And I also wanted to showcase one thing here. Assume you tend to change any of this aspect. Let's say this is the feature type of 64, and you tend to change it into 50 or 25. There's always an aspect of this data not being able to be transmitted seamlessly, because this might not be compatible with the real true for feature type for the data you are trying to use. And so if this happens, it is always vital you don't proceed, but just cross-check your data for it to be read here correctly. And so with this attribute manager, we can always showcase on We can run it here. In this essence, we're trying to transfer this here. Just give it a minute. And an illustration is an indication that you've transmitted data here, and you can confirm this very same 49 aspects of our data is still maintained here, an indication that you are on the right track, and you can proceed with any other attribute manager, attribute transformer you intend to use. In this case, I was to showcase on the capability of this ArcGIS interoperability using one transformer, and based on the data format output you needed it to be, you can always have so many other transformers here to be able to align your data to be compatible with your output data format you intended to use in another system. And having transferred our data here, we can always tend to run the translation. In this case, it gives you an indication that your data has been transferred into the next step. And this is an illustration of the same. And with this, we can always confirm. Yeah, good. With this, can always confirm that we have the very same attributes contained in our first data format. So with this, we can always try to run this here. Give it a little bit time. This is the translation successful, and we having transferred our data here. We can always tend to showcase an aspect of where is that data, and with the data we can showcase it. We can go back where we had saved it, and let me share with you this. Good. We having this data here. We can tend to share an aspect of automation with it here. Before running it, you can choose, you can reschedule this with the interoperability technology. You can showcase this. At what time do you want this to run? Do you want it to run once? How many hours? And having decided, you can always click OK and allow it to run. And that is one of the benefits of that interoperability. I also want to share with you this on why this solution is important. Good. And to finalize my presentation, I would like to showcase on why this solution is important to all our industries out here, considering that industries can maximize the potential of by facilitating its integration and exchange of different systems formats. And with this leads to an improved decision making, enhanced collaboration, and greater operation efficiency, of which this is very essential to any industry. We can showcase an aspect of improved data interoperability. No coding is needed here. When you have a data, you can always showcase how it can be transferred into any desired format. And showcase the automation aspect, which saves time and money, and the format versatility in the aspect. This technology tends to work with more than 200 data formats, and is being so vital for any industry. And the last solution benefit is to customize data, in the sense that we can tend to have data customized in any format that we intend it to be. And I would like to end my presentation there. Allow me to welcome my colleague, Noel.
Thank you, Baraza, for the presentation. Allow me to present my screen, to share my screen. Just a moment with the transition. Good afternoon, everyone. My name is Noel Kurgat. I am a geospatial analyst by profession, currently working with ESRI Eastern Africa as an intern. I have pursued a bachelor's in geoinformation technology from the Technical University of Kenya and recently graduated from a data analysis course. My time in ESRI East Africa has been enriching as I have gained hands-on experience with GIS software, which has enhanced my geospatial skills, which has helped me to come up with solutions to solve real-world applications. The topic of my study, of my solution, is ArcGIS in port operations. The port that I will be focusing on is the port of Mombasa. And this is an aerial image that shows how the port is structured. Mombasa port is the largest and the busiest in East Africa. It is considered a trade route because of its strategic position along the Indian Ocean. The port connects Kenya and neighboring countries to global markets. Some of the countries include Uganda, Rwanda, and Burundi, which are landlocked. So basically, the port handles cargo from different origins in the world. And my solution will focus on 3 key areas in the operations. That is the berths, which are the designated areas where ships come to dock. And this is closely related with the automatic identification system, which is the tracking system used by ships to show their locations. The AIS gives us the ship information, and we are able to know a particular ship, where a particular ship is and which berth it is going to be assigned. My solution will also focus on the assets. For example, in the image, we are able to see certain equipment that facilitate port operations, such as a forklift. We have also tugboats that help to bring in the vessels in the ship, in the waters. The solution will also focus on leases, which are areas where cargo is stored as they await for them to be dispatched. The problem at the port is that we have had manual processes and fragmented data systems, which have slowed down decision making. And this, combined with the increased cargo volumes and inefficient resource use, makes the operations at the port difficult. In addition to this, we also have sediment accumulation in the marine waterways, which threaten the safety in the navigation of ships and thereby disrupting operations. And without timely inspections of all these aspects that I've mentioned, these issues will worsen, making navigation riskier and operations inefficient. ArcGIS then comes in to streamline port operations by integrating data from the marine and the port departments, which improves decision making, and also monitoring sediment accumulation to enhance safety and ensure that there's smooth trading in the region. My proposed solution will focus on bathymetry, which is the study of the seabed and the depths of the water bodies. And basically, this is the topography of the sea. The ArcGIS bathymetry tool is an extension which comes in handy to manage and analyze bathymetric data, which can be accessed from satellite imagery or from satellite imagery. And it has a core system for managing data, which is the bathymetry information system. Some of the uses of this bathymetry tool are like to explore and analyze, to do analysis in the marine environment, for observations and assessment of environmental changes. And it is also used for efficient management and conservation of aquatic environments. The objectives of the solution are: one, to identify and monitor sediment buildup to ensure safe navigation and timely dredging; to ensure to use GIS to manage berths and storage areas, maximizing resources and reducing congestion; and to implement GIS tools to track port assets, optimize maintenance, and extend infrastructure lifespan. Basically, to extend the assets that I had mentioned. To facilitate the removal of sediments from the bottom of the seas and the waterways, a process called port dredging is employed. And from this image, this is the vessel that is used to help remove the sediments from the waterways. This is my solution architecture, which is the entire workflow of the solution from the conceptualization to the end. I first downloaded bathymetry data from online sources. I then integrated the asset, lease, berth, and the automatic identification system data into ArcGIS Pro, where I did my spatial analysis. And I will demonstrate this shortly in ArcGIS Pro. I then published the analyzed data sets into ArcGIS Online. And here we will have a web map. We'll have a bathymetry web map. And here there's also a step of configuring field maps. Field maps is a data application app which is used by the port authorities, crane operators, and terminal operators to collect data using mobile devices. This data is then fed on real-time basis and updated to dashboards. The solution has the lease, asset, and berth dashboards. And this information in the dashboards can be used by stakeholders to come up with better decision making. allow me to show you the solution. This is ArcGIS Pro platform that I used for my analysis. The first step here in ArcGIS Pro was to create a bathymetry information system, which is a central repository where all my bathymetry data sets are stored. And here we have a target workspace, which is an existing geodatabase that we are going to use to store our data sets. We also have a BIS catalog template, which is a table template that defines the attributes of the BIS. And it is located in the ArcGIS product files that come with bathymetry. We also have the raster location, proxy raster location, where these data sets are stored. Upon running, we will have a BIS catalog, as you can see from the screen. It has the 2019 and 2024 bathymetry data sets that I will use in the solution. So basically, this BIS catalog organizes these data sets in one place. And that is the advantage it has because it is lightweight and it helps in data management of the bathymetry data sets. With this data in place, I did an extraction by mask to focus on the area of interest, which is the Mombasa water body, which is the coastal waters of Mombasa. I did extraction by mask for both 2019 and 2024 elevation, the rasters that contain the elevation data. I then did raster calculations between 2019 and 2024 to find the difference in elevation change, which can be seen, which is what is being displayed on the screen. In the elevation change raster, we are able to see different values. So here, the positive values indicate areas of sediment accumulation, whereas the negative values indicate erosion. Also have a reclassified elevation change raster, which has been highlighted here. And from this reclassified map, we're able to see different regions along the coastline. For example, the darker shades of blue, which are along the coastline, show us that these are areas where there's high accumulation of sediments, as compared to the lighter shades of blue, which show areas where there's little accumulation and also areas of erosion. With this kind of data, the government is able to make timely decisions to improve smooth operations by employing port dredging to remove the sediments. And also we're able to learn that the main reason that attributed to such sediments, the heavy sedimentation, is the river discharge of River Tana and Sabaki, which deposit significant loads of sediment from the inland areas. To my second objective, second and third objective, my solution employed the use of Experience Builder to create a custom web application to showcase the entire solution in one platform. Here, I have the home page where we are able to see the port activities at a glance. We are also able to see the key information that my solution will be focusing on, which is bathymetry, lease area management, asset management, and berth scheduling. To achieve, I also have the bathymetry map in the application. And from here, you can see, you can be able to get the information from what I had demonstrated, what the solution had demonstrated in ArcGIS Pro. To achieve the second and third objectives, I use the ArcGIS dashboards, which is a centralized record keeping platform where all the information on the leases, about the leases are. From this dashboard, we are able to see that the total number of leases are 70. And another advantage that ArcGIS comes in is that there is a map that I created and embedded this map in this dashboard. And from this map, we are able to see the leases. The leases are symbolized by the color pink. And it is interactive because when we click on one, we are able to get the information. It is assigned with unique IDs. For example, this is L70. We are able to see the leaseholder, the start date, and the end date. And these are populated by the ArcGIS field maps. As I had mentioned in the solution architecture, we are able to see the monthly rent, the payment status of this particular lease. And we're also able to see various information here. We're able to see the payment status of all the leases, all the 70 leases. We see a high percentage of the leases are paid, and 24% are not paid. We're able to see the utilization status of the leases. We actually see that half of the number, that is 35, are have medium utilization, whereas only 17 have low utilization status. We are able to see the annual revenue and the average monthly rent. And this information is key even to the stakeholders, who are able to use this information for budgeting. And on to our next dashboard, which is the asset management. This dashboard helps us to monitor the asset location, maintenance schedules, and the conditions in real time. We see that we have the total number of our assets are 20. We're able to see the asset details and the location of each detail. For example, one is located at the asset which is assigned a unique ID of A001 is located at berth 1. We're also able to see the maintenance schedules on each of the assets. We see that most of the assets in the port that is 7 are are maintained on a weekly basis, which can be used to explain why most of them are even in good condition. Here we see that 11 out of 20 have good condition. The other advantage is that we are able to see these assets in real time from this map here. For example, when we click on this particular one, we're able to see that it is a forklift. Its condition is good. Able to see also the repair history. The repair history has regular maintenance and it is maintained on a daily basis. And the advantage of this dashboard is that we're able to plan for regular maintenance and which ultimately extends the asset lifespan and reduces downtime, which was a problem which caused inefficiencies. My last dashboard will focus on batch scheduling, and this is the process of managing and assigning docking spaces for incoming and outgoing vessels. Here we are able to see from this dashboard, we are able to see the status of the berths, such as we are able to see the status. We are able to see that 8 out of the 20 berths are occupied, and this can be able to, we can be able to deduct information and make a decision from this. We are able also to see the information such as the berth length, width, and depth, which is used to help in decision making. For instance, the larger vessels dock in berths that are deeper compared to the smaller vessels. And we're able to see the percentage of commodities. You see an equal number of percent in the commodities that are handled in the 20 berths, and which is also good in decision making. From here, we are able to, the berth information is also integrated with the automatic identification system data, which shows the location of ships in real time, which is key in batch scheduling. What I'm doing is that I'm zooming out so that you can be able to see the different regions where the vessels are in the marine waterways. From the map, these green lines represent the maritime navigational channels that the ships use. We can see different ships along the waterways, and from this information, with this data integrated with berth scheduling, we are able to see information on the origin port, the destination port, and the estimated time of arrival. We are also able to see the assigned berth that each vessel has been assigned to. And this maximizes resources and reduces congestion. The benefits of using ArcGIS in port operations are: one, through sediment monitoring, we have enhanced safety and reduced accidents along the waterways, hence improving the operations at the port. Two, we have improved efficiency at the port as a result of the streamlined processes at the berths and the lease areas, which minimizes delays and maximizes the throughput. And lastly, we have reduced operational costs at the port through strategic investment investments and management of resources, improving the operations. And this leads to the overall success of the port operations. Thank you. I'll now introduce my colleague, Martin Kimodo, who will take us through his solution.
Thank you, Noel. My name is Martin Kimodo. I'm a graduate from Moi University. I did a degree in Bachelor of Arts Geography. And I want to express my sincere gratitude for the opportunity to be an intern here in Nestle. The experience has been incredibly rewarding, and I have learned a great deal from a talented team. I've gained more practical skills, professional insights, and deep understanding in GIS field. That have fomented my career path in GIS. My project was in petroleum data management with the GIS. You all understand that data management is collecting of data, organizing it, storing and analyzing, and also managing it. In petroleum exploration, it is a wide area, and it is segmented in three regions, that is upstream, midstream, and downstream. My main focus was in upstream petroleum exploration, that is data management, which is very essential, that it is the first phase during the petroleum exploration, Problem statement is that upstream petroleum exploration involves diverse data from different sources, and mostly in different formats, and it makes it difficult for the government to publish the relevant information about the industry. This, we find that data from upstream petroleum explorations, they are scattered everywhere. In others are in different formats where the government cannot be able to organize it in one area and publish it for investors to have an eye on it. That it also indulges the stakeholders in this industry to make relevant decisions on where to invest it. To appreciate the capability of ArcGIS, he found that besides data management, one is able to map the data that is in this case in data from well data and block data. You can map in ArcGIS environment in either ArcGIS Pro, and then publish it to the public using hub site. And also another capability is that using field apps such as field map, one can be able to gather data from the field, that is well data and its attributes, and then integrate it to the ArcGIS platforms. My solution was to work on creating a geodatabase whereby all the data will be consolidated in one area. That is all the data from exploration, that is from the SDP, from NOC, all the data areas which is scattered everywhere will be in one area, so that the investors can be able to access it easily. The objective of this solution is to create that geodatabase that consolidates data from various sources into a single unified platform. Another one is to assist government in marketing oil and gas resources. This is through mapping the regions where petroleum hydrocarbons is available, and the investors can invest in these regions. Another one is to streamline data access to the area of interest. That is, the investors can be able to have the data which, like in each block, they can be able to get the data relevant to the objective or the goal to invest in them. That is either well data, well log, well block, which is in either licensed or not licensed. The investors will be able to have this. My solution architecture is that the data which I'm talking about will be gathered from National Oil Cooperative Kenya. and from EPRA and SDP, this type of data is geological data, geophysical data, and the other documents which can be published in the online site, so that the investor can be able to access it easily. This data is then in here I'm able to work in two data sets, that is well data and the block data, and other data which was like Petroleum Act, which is in document forms. I published it in the ArcGIS Online, and data from well and block I put it in the ArcGIS Pro to analyze it and create an interactive map. Okay, this is a ArcGIS Pro environment where I created my geodatabase, which have both data from block and well, and I incorporated the attributes in it, and created the interactive map, whereby when you click one area on one region, there's a pop-up showing the attributes of that block, either with the block in which the region it is that is based, if the block is licensed or not licensed, and all the other required, all the other data which can be an interest to the investor. I published this this map to ArcGIS Online, where I created the website. This is the website which I created, whereby the government can be able to publish all the documents, all the data which is associated with upstream exploration, and a site where the investors or the public can be able to see the data in various forms. It has for 5 tabs, whereby in every tab there is different content in it. In home tab, it is where the description of the platform is given. Like in this, I'm saying that it is a centralized platform. It's designed to streamline the management of upstream exploration data to access seismic data survey, well logs, geological model, and in real-time field data in one secure location. That's in this home tab. It's just give a small descriptive about the platform. In the content tab, it is where it contains all the data the government can publish or showcase to attract the potential investors in the industry. And it is also where the investors can be able to download the data, like regulatory measures which can be critical in their decision making, and also to have a look in the interactive map showcasing the resources, petroleum resources in Kenya. For instance, the investor can be able to go inside and maybe click in one of the well. In that well, you'll see the status or the well type, the basin which it is in, the operator, and maybe the well content. That is either it is gas or oil. You're able also to see the block name, the block number, the basin which it is, if the block is licensed to any operator or not. That can be very critical to its decision on whether to invest in that region. In this content tab, there are also some summary report which can be used by like geological surveyors or geologists, engineers, to have a look in each well, that is well data, which are in PDF forms or which are documented, and they can be critical in giving their input during the exploration, that is, and investing in a certain well. I might click this one, just one. In this site, it gives the client or the viewer to download the document and be able to go through it. In this case, engineer or geologist, engineer or people who are working in the upstream explorations can be able to see the data, that is the well data of a certain well, and be able to give an input. They can go in either in the field to confirm if the data in the site is the one which is the one which is in the well. You can see that this is the kind of data that geologists can understand. Beside well log data, the content tab also have the dashboard for executives to provide the dashboard, which provide the evidence-based insight to formulate effective policies. In this case, the executives can see the number of wells, the total number of wells in Kenya, the content, which either it is dry, it has gas content, or the oil, or both gas and oil. In this dashboard, executive also can be able to see the number of licensed and unlicensed blocks, and also can give the government some input or to smoothen the licensing processes by giving step by step on how to obtain the license or to streamline the licensing. Also, in the content tab, the government can also be able to showcase the exploration areas or resources areas through a video. The good thing about a site is that one can be able to embed the video, which one can also show, because the video and also want to tell a compelling story. And in this case, government can be able to utilize the capability of the app to have videos of petroleum and exploration blocks and wells in the regions or the basins. In the site, another tab, the next tab contains regulations, that is the regulations from maybe EPRA, which give the licensing to the investors. Investors can be able to go to the site, have a look to the act, maybe Petroleum Act, and download it and see whether they can comply. They comply with the regulations of the country in petroleum exploration. You can see that's a very huge PDF form. Just 200 pages, one can go through it. About this site, another tab contains this feedback. This one, I embedded the field ArcGIS survey 123, whereby government can be able to get a response from the public. Okay, just to fill the form and publish it to see it, for the government to see the kind of maybe data they're supposed to publish. I just populate it very fast. After submitting, just a minute. One can be able to go through it to the backend of the government site. They can be able to go through the form. And they see the kind of response they are getting. Like you have just operated the last one. This is the last which I've just populated. The government can be able to see the kind of response and analyze it so that they can decide which kind of data they're supposed to publish all the exploration data people can able to access. The last tab was about contact, whereby if an investor is interested in a certain area or you're in a hurry to call or to contact the government about the data, about the licensing, you can call them through the information in this tab. To the solution of this, to the benefit of this solution, we find that centralized data storage and management consolidated data in one unified platform, which is assessed and updated by authorized persons, hence it solidifies data credibility and security. The government is the one which is responsible to update this data, hence ensuring the data is credible and secure. Another benefit of this solution is that the hub sites help to give a clear view of untapped resources and gas resources where a government can market them to potential investors. All stakeholders are able to make a data-driven decision. That is whereby the website give the access to the investors to download their data or to visualize the data which are critical in their decisions making. That's the end of my presentation. Thank you very much. I would like to welcome the next colleague, Elia.
Thank you, Martin. Let me allow to share my screen. I hope you see my screen. Good afternoon, everyone. Let me introduce myself. My name is Elia Madalaka from Tanzania, and I hold a master degree in Geographical Information System from the University of Dar es Salaam. With deep passion for the application of spatial data and technology, I specialize in utilizing GIS to analyze, to manage, and to interpret GIS to solve complex problems. During the internship, I have learned various geospatial techniques such as data analysis. So let me back to my project that was given to me, and I have been working on my project is effective catchment delineation for drainage structure. So today I'm going to showcase the capability of geographical information system, GIS, and remote sensing to carry out the catchment delineation. So I will start to introduce the topic. What does it mean? Wherever you see catchment delineation is a process of identifying and mapping the area of land that drain into a specific point, such as drainage structure. The drainage structure might be culvert, bridge, or stormwater inlet. By doing this is very crucial or important because it enables planners and engineers to comprehend the amount of water that enters the drainage structure and make appropriate plan. Uh, uh, my project was done in the in Tanzania, Dar es Salaam city. As you can see on the screen, the river Msimbazi pass. This is introduction of my topic. Msimbazi Valley is built first green space in the center of Dar es Salaam. Historical river serve as an important water source and the fertile floodplain provided prime land for agriculture and animal grazing. However, the once perennial river is now season. The bed river is almost completely dry for much of the year. And during the rain season, the river change its character dramatically. When the rain come, the river revive. So this is my problem of the project. Msimbazi area face a significant problem in water, stormwater management, flood risk, water quality, and pollution. However, the existing drainage infrastructure is seemed insufficient to cope with the increasing volume of runoff, resulting in frequent flooding, erosion, and water quality degradation. Despite the presence of drainage system, the catchment has not undergone thorough delineation to define the boundaries and hydraulic behavior of which is catchment, of which is subcatchment. So the aim of this study was carried out to define the boundary of the catchment through using the hydro pro within the within the ArcGIS Pro. By using advanced geospatial technology, we will enhance the understanding of the area hydraulic, informing the design and placement of drainage structure. So the main objective is to use ArcGIS tool to perform hydrological modeling and spatial analysis to define catchment area. And my specific objective is to delineate the watershed boundary of Msimbazi catchment. This is my solution architecture that was used in this study. I have started with data collection. The data was used in this study is digital elevation model that was acquired from the open source called USGS Earth Explorer, United Scientific Geographical Survey with 30-meter resolution. Digital elevation model is a raster data that representing terrain elevation in the grid formatting. So this is the data that was that I was able to acquire and help the analysis to carry out. And number two, data processing. Here, the data was reprocessing here. Since the dam can sometimes have smaller depression or sink where water is in collecting assumed to be trapped in. So this should be filled to avoid inflow routing. And number three up here, data analysis using HydroPro. This is a place where the all analysis were carried out by using HydroPro. The HydroPro is a vital tool for hydrological modeling because it simplifies the analysis and management of water flow data, and also can be able to enhance accuracy of prediction and support effective watershed and flood management planning. So, and the number four, visualization and mapping. Here, after I was able to carry out the analysis, and the software was able to bring out the output that is catchment. So you can visual your output here through maybe I used the ArcGIS Pro to visualize my output. So this is methodology that has been used to accomplish or to carry out this analysis. Let me back. Let's go quickly to showcase the demo. This is ArcGIS Pro environment where analysis was carried out here after acquiring digital elevation model, that is here, digital elevation model, this one, as you can see on my screen. Then I will be taking you through how to carry out the catchment delineation through Hydro Pro. So here we start. You can start to explore this dam to see the spatial reference. Or so the first step. The first step is to fill sinks. So you have to go to the analysis tab, then you click tool and light fill sink, as you can see on my screen. So the important things to note here is that you want to use all the toolbox that say Archhydro, like this one, Archhydro. Then you click here. This will be opened. Then it will ask you to fill some parameter. As you can see here, you fill them, and the output name will be fill. So then finally you learn here. After learning, you will see this output like this. So I will go quickly to the next step. The next step is we are going to generate flow direction. Flow direction. This dam has been filled sink. So again, you have to use you have to search through the geoprocessing tool. Then we are going to search flow direction. Flow direction. This one, flow direction. Here, input idle dam field. We will fill the field that was our output, and also this has been done before. So I will show you as a demo. So after that, the output will be FDR TIFF. So you learn. After learning, you will see the flow direction. This one. This is flow direction. That water flow in each of these pixel.
Sorry, Elia, we cannot see your screen.
I cannot see my screen. Okay, let me share. Okay. Okay, this is flow direction, as you can see in right here. And the next step is to flow direction. Then we are going to the flow accumulation. Flow accumulation. You do as usual. This is the flow accumulation. We're going to search for flow accumulation. Flow accumulation. This one, flow accumulation. Here in flow accumulation, it will ask you to input flow direction. This one, flow direction. Then you learn. After learning, you will see the flow, the election, as you can see on my screen, that was generate the stream like this. So the flow direction is a number that tell me how many cells are upstream of one specific cell. So the next step is we are going to define the streams. So let's go to define the stream. In this process, we will search the stream delineation tool called stream delineation. Stream, this one. So here we are going to define stream. This will ask you to input to fill the flow accumulation raster. This one, flow accumulation raster, and you will fill some parameter like this. Then you run. After running, you will see the output. This one, you can see these two image is differ like this. Let me uncheck this. This is stream has been defined. You can see, and the next step is we are going to now we will see that the different streams that as different color. So we are going to stream segmentation as usual. Stream segmentation, this one. Then you click segmentation, and we will input stream raster, this one, and input flow direction, this one. This will be we will keep by default because we don't need this. So after that, you running here, then you will see this, the output like this. This will mean that the stream color, the stream color have different. The stream have different color. That means the stream has been segmented. As you can see. So okay. Sydney, can you see my screen?
Yes, yes. Please proceed.
Okay. So the next step is we are going to generate catchment grid processing. That is catchment delineation. So we are going to use catchment delineation here. We write catchment delineation. We use catchment delineation grid here. Then we have to fill the input flow direction that has been created. This one, and we will fill the link cluster. This one. Then you run. After run, the software will bring out the output like this. This is our output, and we don't have this raster. I want to change into polygon. So by doing this, I will use catchment polygon process. We want to change into process, so then we will import this one catchment. Then we run. After running, we will see the catchment polygon, this one. Then the next step is adjoint catchment. Okay. Then we fill some parameter here. Then we run. After running, we will see the adjacent, this one. So after doing that, the last step, we are going we will able to delete to a point, and so we are going to delete a point from so if you want to delete a point, you have to create the shape file from your geodatabase. So after doing all processing, we will obtain the output like this, and this is a final output that that was created through this project. So let me stop sharing and back to solution benefit. The aim of this project will be focus on water management, management, and aids in understanding the movement and the availability of surface water within a specific area. And the another will flood risk prediction and management. Here, the catchment delineation helps to identify flood prone area by understanding how water flow within a watershed. Also, sustainable development, and final, resilient infrastructure. Here, engineers will be able to design stormwater management system and ensure that road, bridge, and building are built. So thanks for your time. I would like to welcome Sydney for the next.
Thank you so much, Elia, for that wonderful presentation. And I'd like to thank all the interns for the work they put in for this quarter. I can see there are a few questions from the chat section. One of the question is directed to Sheila. Sheila, are you there? Would you kindly answer a question that was asked by Faith? Does it mean that the drone will be flown every time a new inspection has to be done? Sheila, are you there?
Yes, I'm here.
Okay.
I think for this specific question, such a project maybe would be done on a large scale because the sample that I did was for one building. So I think such an inspection would seem to be expensive in the long run. But given a scenario